over polynomials, day one, a solution guide. So we look at this first function, p of x, and we notice that it's a quadratic. It's a quadratic because its highest term is this 6x squared. I usually refer to the highest one as the big dog because the 7 and the 3x, they control some things like the y-intercept and the location of the vertex. But really, it's this guy right here. It's the big dog that really determines the general shape. And we know since 6 is a positive, which we would call the lead coefficient, that's going to be a positive quadratic, and a positive quadratic looks like a nice smile. So we are just on this term alone, we know that it's going to have this general shape. It is a polynomial because it is of the polynomial form that we will discuss I guess, we discussed in class, and I'll show you kind of at the end of this worksheet. But there's no negative powers, there's no fractional powers, there's no square roots or logarithms or cosines or sines or anything funky. It's just everything is of the form a, some number, times some x to some whole number power. So yes, it is a polynomial. It's not in standard form. Standard form has it written in the correct order of squares, then linears, then constants. It is a quadratic. It is degree 2 because the highest power is 2, so degree or order. There are 3 terms here, 1, 2, 3, which makes it a trinomial if we were going to classify it by the number of terms. The lead coefficient is 6 and the constant here is 7, and we know that the constant for polynomials is also the y-intercept. Here's the general shape, and then this says what is happening to our function as we let x go to infinity. And this is basically saying what's happening to the function as we go really, really, really far to the right on the graph. And what's happening when we go to the right, the function is going up. So it's going to go to infinity. This says what's happening, what's the limit of our function as we let x get closer and closer to negative infinity. All that's saying is what's happening to our function as we scroll to the left. Well, it's also positive infinity. Okay, these are end behavior questions. And so it's really saying what's happening to the right on our graph, what's happening to the left on our graph. Okay, next one is an x cubed term. So it is a polynomial. It is a cubic. It is already in standard form because the powers are going in decreasing order. We would classify it as a cubic because of x cubed. It's degree 3. Of course, the highest power is 3. The number of terms, however, there are only 2 terms, boom and boom. The lead coefficient is a negative 4, and we know that a negative cubic function has this general shape. There's not always 2 humps because it might just kind of slide down nice and smooth. And that's where these other terms end up affecting the size of the humps and so on. The constant is 0, so the y-intercept would be 0. You can see if you plugged in 0, you'd get 0. And then the end behavior, what's happening to our function as we go to the right? It's going down towards negative infinity. What's happening to when we go to the left? Well, it's going up. So then the left end behavior is positive infinity and the right end behavior is negative infinity. And that will actually be true for all negative odd powers because, a cube is going to be, up and down like x to the 5th, x to the 7th, and a negative. Well, negative is going to go up on the left and down on the right. All right, so look at our next one. Our next one, it's not written in order. Because you look at this first, like, oh, is this going to be a cubic? And you're like, nope, look, the big dog is right here. The big dog is a positive x to the 4th, which will look like a W. And again, it may or may not have all these humps, but again, it's going to generally look like a smile, but it's going to have some extra humps. So it is a polynomial. Writing it in standard form is just taking the fourths and the cubes and the squares and the linears and the constants. We would classify it as a quartic. That's just the name for something with x to the 4th, degree 4, x to the 4th. The number of terms, this one has 5 separate terms, 1, 2, 3, 4, 5. The lead coefficient is a positive 7, and the constant, of course, is the y-intercept, which is 9. If we scroll to the right, and if we scroll to the left, we go up and up. So both end behaviors are positive infinity. All right, this one's a polynomial. It's just a linear polynomial. It's already in standard form, and again, it is linear. It's just a line. It's degree 1 because that power there is a 1. It's just got two terms. The lead coefficient is a negative, so it is going to have that general shape of up on the left and down on the right. The constant is 1, and then again, it was exactly what I just said. When you go to the right, it goes down. When you go to the left, it goes up. Okay. This one is a negative quadratic. Okay, so yes, it is a polynomial. I need to rewrite it into standard form, so those two aren't in the right order. So I had to rewrite. It is degree 2. It does have 3 terms. The lead coefficient is a negative 4, so we know it's going to be a frown. The constant is just that 1. And this is the key does have a mistake on this one. This should be negative infinity and negative infinity. If you look at the function, as you go to the right and as you go to the left, both go down to a negative infinity. So there should be a little negative sign there. Like I said, both end behaviors are negative. This g of x, this is going to be a negative x to the 5th. It's a polynomial. It is already in standard form. There's no special name for anything higher than a quartic. So this is just generally just a polynomial. It is order 5. It's got 3 terms. The lead coefficient is a negative. So we know a negative x to the 5th has this general shape. They don't always have humps like that. Sometimes they're a little smoother, but they typically have those humps. The constant is 8. And if you look at it, what's happening to the right, it's going to be going down to negative infinity. What's happening to the left, it's going to be up to negative infinity again. This is another example of a negative x to some odd power. Negative odd powers are going to have this general up and down, just like this one is a negative odd power, and this one is a negative odd power. If they were positive x cubed, it would have been flipped the other way. If it was positive x to the 5th, it would have had an arrow up on the right and an arrow down on the left. And then these end behaviors are switched. Okay, so this one's not in order, but it is a negative x to the 4th. So yes, it's a polynomial. There's no negative powers up here, no fractional powers. Rewriting in standard form makes it look like a negative x to the 4th, which we call a quartic, degree 4, 3 terms. Lead coefficient is this negative 1 right there, which says it's going to be like a frown down. So this kind of looks like an M, or a positive x to the 4th looks like a W. The constant is the 10. And both end behaviors are both down. Down when you go to the right and down when you go to the left. Okay, and the last part says, are these function of polynomial? Sure, it's just a horizontal line, which is a constant function. It's degree 0. It's like x to the 0 power there. Nope. Can't have that x in the denominator. Nope. Can't have a fractional power, which is what a square root is. Nope. Can't have a fractional power, that 1/3. Nope. This is a circle. Nope. That next one is an absolute value. And the next one is kind of tricky because it looks like there's square roots and stuff, but the square root is just the coefficient, which is totally fine. Pi, it's just the coefficient. It's not the power. The powers are fine. The powers are 3, 1, and then this is just a constant. So yeah, that's totally fine. Same thing. Oh, nope. This is fine. Having a square root of 3, that's fine, but you cannot have a negative power there. That makes it so that one is not a polynomial. And this last one, yeah, if you multiplied all that out, that'd be some x to the 5th, x squared, stop, blah, blah, blah. But it would still be of the form, and then here's our definition. A polynomial always looks like that. It's a number, x to some power, and as long as these powers are non-negative and not fractions, then you're good to go. It's got that general form where this guy is the highest degree, and it just keeps going down and down and down. Okay, so hopefully this solution video guide kind of helps you through our intro to polynomials.